Continuing our overview of Java, we'll now turn our attention to key functional programming concepts and features supported in the language. These features were added in Java 8 and expanded thereafter. We'll start our discussion by considering how computations can be treated as evaluating math functions that can be composed together into pipelines. We'll look at an example as a case study which generates and checks count positive odd random numbers and then prints which are prime and which aren't. Java functional programming has its roots in a formalism known as lambda calculus. And one of the key themes in lambda calculus is that computations are treated as evaluating math functions. A math function, as you undoubtedly know from early days of math when you were in elementary school, finds a relationship between an independent variable x and a dependent variable f of x, which applies the function f to x to get an output. Ideally, each function in functional programming is pure, which means it operates only on any parameters passed to it and has no side effects on memory or input-output. It just returns results. Here's an example of a pure function. This pure function returns 0 if the parameter n is prime, or the smallest factor if n is not prime. Recall that a prime number is a natural number greater than 1 that is not the product of two smaller natural numbers. We'll talk more about the isPrime method when we review this in the actual source code walkthrough. One of the other key themes in functional programming is that functions can be composed. In other words, the output of one function serves as the input to the next function in the chain. Here's the case study example we'll use to illustrate the key themes of function composition in this part of the lesson. This example, which is found in the EX1 project in the FP folder in my Modern Java repository, generates and checks count positive odd random numbers and prints those that are prime and those that aren't. The way it works is it starts by generating a stream of random integer values from 1 to the integer max value, and it only considers odd integer values. If you're an even number, you certainly can't be prime. And so we filter out anything that's even and only look at the odd numbers. The next thing we do is we end up calling this method reference to check to see whether the number is prime or not. And that, of course, uses the isPrime method we looked at earlier. We then limit the amount of numbers considered to only count of them by using a limit operation. And then the final operation in the stream prints the results. So you can see we basically flow the information through the stream. Note how the Java Streams framework applies the fluent programming style with chain method calls to support function composition in modern Java. Let's now go ahead and walk through this case study in more detail. And again, you can find the case study at the link at the bottom of the slide. We're now in my IntelliJ project for case study EX1. This example uses the Java Streams framework to compose a pipeline of functions that generate and check S max count positive odd numbers generated randomly and prints those which are prime and those which are not. It also shows how to use the Java record type. So let's take a look at the code. We're going to print out 20 positive odd random numbers to check for primality. Here's the main entry point into the program, which calls the check for primes method with the count that we provided above. We define a Java record called prime result. A record is a plain old data structure that in this case contains two fields. One is the prime candidate, which we're going to be checking for primality, and the second is the result of calling isPrime on the prime candidate, which will either be 0 if it's a prime number, or it'll be the smallest factor that can be multiplied to get the prime candidate. Here's the check for primes method. As you can see here, it's a stream, and it generates and checks count positive odd random numbers and prints which ones are prime and which ones aren't. Here's what it does. We start by generating an infinite stream of random positive integers in the range 1 to the maximum value of an integer, which as you can imagine is rather large. The next stage in the stream will involve applying the filter operation, and this will be done to only allow odd numbers. There's no sense in checking to see whether an even number is prime, because of course it couldn't possibly be prime. This passes the isodd method reference. Here is the isodd method, which takes an integer, and we apply the bitwise AND operator to determine if the integer is odd or not. If the ANDing of 1 to integer returns 1, that means that it's odd, otherwise it's even. The next operation in the stream is called map to obj, and it's going to be used to check each odd number which survived the filter call to see if it's prime or not. It does this by being passed the checkIfPrime method reference. Here's the checkIfPrime method, which is a pure method which is going to take the prime candidate and create a prime result that it will then return back to the caller. Prime result, in turn, is going to be implemented by passing in the prime candidate as the first parameter, and the result of calling the isPrime method with the prime candidate as the parameter. Here's what the isPrime method looks like. Note, by the way, this method is a pure function. It takes in a parameter, does some computation, returns a result, and has no side effects on memory or I/O. The way that isPrime works is it has a local variable n, which is initialized to the prime candidate. It first just does another somewhat redundant sanity check, seeing if the number is a multiple of 2. If it is a multiple of 2, it can't possibly be a prime number, so we return 2 as the smallest factor for this non-prime number. Then we run a little loop here that checks to see whether or not the number is prime. And it does this by having a loop variable called factor that starts out to be 3. And you can see here we're going to skip over even numbers. So we're going to go 3, 5, 7, and so on. As part of the loop condition, we multiply the factor by itself and check to see whether it's less than or equal to n. As long as it's less than or equal to n, we then come in and run this if check. If we take n and mod it by the factor and it returns a 0, that means the prime candidate was not prime because we could multiply two numbers together to get that number. If we make it all the way through the loop and nothing has returned the factor, that means the prime candidate was indeed prime. Not necessarily the most efficient way to do prime number checking, but it's good enough for our purposes here. So let's go ahead and take a look at what happens next. The next thing we do is we limit the count of items considered in the stream to be the parameter that's passed in, which in our case is going to be a relatively low number 20, but it could be whatever you pass in. And then the final operation in the stream will print the results. So this is what's called a terminal operation. And for every element that's made it this far, we're going to go ahead and print the results by calling the print result method reference, which is connected to the print result method. What this method does is it checks to see whether or not the result of the prime result record was 0. If it was not 0, that means it was not a prime number, so we indicate it was not prime. Otherwise, it was a prime number, so we go ahead and print the prime number, what we have here. So let's go ahead and take a look at what happens when we run this, and you can see what the results are. So what we have is a bunch of random numbers. There's 20 of them. They're rather large, as you can see, and some of them are prime, and some of them are not. And if it's not a prime number, we get back the smallest factor. So that's a quick walkthrough that just illustrates how you can compose together a series of functions using the streams functional programming features in Java. Of course, we will talk about streams in much more detail later